Hello everyone and welcome back to the C++ 3D game tutorial series. In this 31st video tutorial, we will see how to render the images. In particular, we will see how to render a specific image on the screen through DirectX Tool Kit, how to create the image component, and in the end, we will see how to create a simple HUD. As always, we will face three main parts: requirements, design, and implementation of all the necessary things to render the images. So let's start with the requirements. We need a C++ IDE. In this series we use Visual Studio 2019 Community. The target platform is Windows. The target graphics API is DirectX 11. And last but not least, a bit of knowledge of C++ programming language is recommended. Now we can start the design part. In this tutorial we are going to see how to create and render another core element of the user interface, the images. The rendering of the images can be approached in many ways. Since we are using DirectX, we can render the images by exploiting again the DirectX Tool Kit. In particular, we have to use the Sprite Batch class. As we have said in the previous tutorial, Sprite Batch allows easily to render sprites and textures on the screen. That said, let's dive into the design of our class diagram. In the first place, we have to create a Sprite Batch instance inside the render system that will allow us to render effectively the images on the screen through DirectX. Then, in order to easily allow the user to add images on the screen, we have to create the image component class. Finally, as usual, we should handle the rendering of this component inside the update method of the graphics engine class. In the end, we should obtain this final result. If you have questions, doubts, or comments about this topic, don't hesitate to leave them in the comment section of this video or in the Discord server. The link to the Discord server is available in the video description. Also, if you find these tutorials helpful, please consider to support their development on Patreon. Every single contribution makes the difference, regardless the amount. Very well, we have gathered all the necessary information to start the implementation. As first thing, let's remove the old folder, since all the source code files inside it are not necessary anymore. Then we have to fix a little bug that shows up when the window is completely collapsed, and so when the width or the height is 0. This issue happens because we create the swap chain by passing an invalid width and height values as parameters. To solve this issue, we have to simply prevent the creation of the swap chain with a width or an height of 0 value. At this point we have to fix another little issue related to the gain loop in the Win32 C++ file. Here we use if with the peak message function. We should use instead a while loop in such a way to process all the messages at once. Very well, let's finally start to render the images. As first thing, let's create the image component class in the entity folder as usual. Then let's add the constructor and virtual destructor. And don't forget to inherit from the component class. Last but not least, let's add the onCreateInternal virtual method. At this point, let's implement this method as we have already done with the other components. Once we have finished to prepare the image component class, we can go to the graphics engine header file, and as we have already done with the other components, let's add a set of image components. Don't forget to add a forward declaration of image component class inside the prerequisites header file. Now, in the Graphics Engine C++ file, let's support the creation and removal of image component inside the add component and remove component methods, respectively. So far so good. The next thing to do is to furtherly implement the image component class. Let's start by adding a texture pointer attribute and a rect attribute. Let's also add the usual setter and getter methods. Cool, what's next? Well, we have to effectively render these image components. So let's go to the graphics engine C++ file and in the update method, let's loop over the set of image components above the text components loop. In this way, the images are rendered in the background and the text are rendered over the images. Cool, what do we have to do now? We have to find a way to render effectively the textures on the screen. To do that, let's go to the render system header file and let's start to include the sprite batch class. Then let's add a unique pointer to an instance of sprite batch and let's call it image batch. Let's exploit this occasion to remove the old and, at this point, useless attributes related to the vertex and pixel shaders. Let's also remove the commented code. So far so good. At this point we have to do nothing but add a new method called drawImage that, as the name suggests, draw a specific texture on the screen. Let's also pass a rect parameter in such a way to control the size of the rendered image. It's the time to implement the method. The first thing to do is to initialize the image batch object in the constructor. Now we can actually implement the drawImage method. As first thing, we have to call the begin method, in which we have to pass some parameters required by sprite batch to render the sprites or the images in a specific way. Then we have to transform the size of the image in the rect format. At this point, we can finally render the image by calling the draw method. This method requires the shader resource view of the texture that we can provide by making the render system a friend class of texture2D class. And then we have to pass the rect object defined previously. Last but not least, we have to call the end method. Very well, now we can turn back to the graphics engine C++ file and we can finally call the drawImage method of the render system class. Pay attention to pass the position as the first two values and the width and height as the third and fourth values respectively. We have finally finished to implement the rendering of the images. Don't forget to include the image component in the whole header file. What's next? Well, we have to effectively add images on the screen. So let's go to my game header file and let's define a bunch of entities. One entity for the logo, for example. Another one for the crosshair. Another one for the elf indicator. And the last one for the ammo indicator. At this point, we can go to my game C++ file and in the onCreate method, let's load the various texture files for our image components. So let's load the logo, the crosshair, the elf, and the ammo. The only thing that remains to do is to add the various entities as we have already done with the text entities. Let's start by adding the C++ 3D Game Tutorial Series logo. At this point, we should only pay attention to set the image, the size, and the position of our image entity. Let's see if it works. Unfortunately, there is an issue. We have forgotten to include the rect header file in the image component header file. Let's do what we have already done with the logo with the other UI elements. That's all for now, folks. Today we have seen how to render the images on the screen. The next time we will finally see how to implement the collision detection. I hope you enjoyed this video. See you soon. Thanks for watching.